Alright, I'm going to go through one more time. Do it with my sequins here so you get a visual. And please go back and review these videos. If you have no idea what's going on in class and you need to review, all you have to do is go onto YouTube, and my channel is called Miss Craig's Anatomy. I'll double check that. I think that's what I named it. Miss Craig's Anatomy. And I will send a link out through Remind 101 to where you can get to it. Please go review these videos. And some of y'all have emailed me and said, I don't have a clue, Craig. I don't know what's going on. That's fine. I understand that. But I made these videos hoping that they would help. So please go back and review them before the test if you need additional help, or you need to go back and review your notes or add to your notes, or maybe you missed something or missed a day and you need to go back over it. All right, one more time for muscle contraction. Here's your actin filament, the thin myofilament within a muscle cell. On that actin filament, you're going to have these active sites. Those active sites are also called myosin binding sites. If they're called myosin binding sites, then that's clearly where myosin is going to bind. Well, they get covered up by this troponin tropomyosin complex. Troponin are the blue rhinestones. The tropomyosin is the pipe cleaner. They're covered up. Well, we got to get them uncovered. We have to uncover these active sites on actin so that myosin can bind to it. That's the whole goal of muscle contraction. How do I expose the active sites on actin? I need to move this out of the way. In order to do that, I have to get calcium. Calcium is stored in the sarcoplasmic reticulum of the cell. So it's going to be pumped out of the sarcoplasmic reticulum because ACH bound to the receptor and told the muscle cell to do that. The calcium is going to come in and bind to troponin. No, it doesn't just bind to one, but you get the idea. Calcium binds to troponin. It's going to cause the troponin tropomyosin complex to shift out of the way. When it shifts out of the way, it is going to expose the active sites on actin. That's going to leave them open to where myosin can come in and bind. Myosin binds to the active sites on actin. When they do that, they're going to flex. When they flex, they're going to slide inward, and everything in the whole sarcomere is going to shorten. Here's a sarcomere before contraction. We're running from Z disc to Z disc. If you look after contraction, what you get is a shortening to where these myosin heads have bound to the actin and walked their way inward and caused that whole entire sarcomere to shorten, which in return causes the muscle to contract. Okay, email me if you have questions, but please go back and review if you're struggling. Your test will be next Friday. If things are going as planned, you will have a study guide, you will have a study day, but that does not mean that you can sit and get it in class. So this is a tough topic. Make sure you're reviewing it. Don't get overwhelmed. But the videos are always there. If you need help, email me if you have questions. See y'all later.